folks, welcome out there this afternoon. We are so glad you tuned in to TNLearn Mathline Summer School. I'm your host, Ernie Roberts, and I'm just glad you're here. It's summer and the living is easy, and you've tuned into Mathline. It's great to have you out there with us today. It's one of those shows where we're going to do a little bit of math. We're going to let you be laid back about it. It's not a call-in day, but we do want you to get some pencil, get paper, take some notes, whatever you wish, work some problems along with me, all right? And we'll guide you through it, and we'll do some fun math. Have no idea what today's story is about? Actually, I do, but let's find out anyway. What we got coming up on our slate, guys? What we got going here? A potpourri. Yes, we'll spell that right. Potpourri of percents. That means this is going to be all sorts of random mixes, you know, and hopefully it'll all smell good like that potpourri that you sizzle in your homes do also, all right? When it's all said and done at the end of the show today, all right? But let's have a little bit of fun today. It's going to be just a mix of all sorts of things, but they're all going to have things in common called percents. So let's see what we've got up our sleeves here. First question here. It says to write 68% as a decimal and as a fraction. All right, now, folks, decimals are fractions, all right? Please understand that. If we read them, you know, pretty properly, I know we like to say 0.5, 0.2, but really those are tenths, like 5/10, 2/10. So what we're going to do, we're going to write that decimal as a fraction, as a decimal fraction, and then we're going to make it into a fraction with two integers, and we're going to reduce them, obviously, as far as we can go, all right? So let's take a look at it. We've got 68%. Go ahead and write that down at home where you are. And let's see what we're going to do with 68%. Now, when we think of percent, we always have been writing in many of our formulas, when we use the proportion formula, we've been using that percent over 100, all right? Which is basically, in this case, we'd be saying 68 hundredths. Well, how do we write that as a decimal? 68 hundredths. That would be decimal with the 6 and the 8 following right after it, okay? Simply stated, and I'm going to make it as easy as possible here, because this does represent hundredths, we're going to simply move that decimal two places. It was right there, we move it over to where it will be in front of the 6, all right? So that's how we deal with that. That's how we deal with that. Now, as I said, that means 68 hundredths. So if we're going to write that as a fraction, first of all, we're going to make it 68 divided by 100. And then we're going to look at what can we do to reduce? What can we do to simplify that fraction? It's rather big. It's rather big. And we always like to have them in the lowest terms. In other words, reduce them down. So let's see. First of all, I noticed 68. I noticed 100. They're both even numbers. So let's attack it in that respect. Let's go ahead and divide by 2. Some of you may think, I think there's more that'll divide out. Well, let's take it one step at a time. All right, when we divide 68 by 2, I'm getting 34. And underneath that, I'm getting 50. Well, you know what I'm noticing? We've got a fraction that's got two even numbers again. So we can go one more time here. Let's divide by 2, both of these. And let's see where it takes us. 34 divided by 2. Gosh, half of 34, folks, let's think about it. It's going to be, that's not too hard, is it? It's going to be 17. And if we take 50 and divide by 2, we are going to end up with 25. So 17/25 will be our fraction in lowest terms. That means it's the same amount as, we look at that, sometimes see 0.68, 68 hundredths. If you're thinking money, think of it 68 cents. That part of a dollar is 68 cents out of a dollar. But what did that refresh us down to? 17 out of 25, or 17/25. So there's our looking today. A little bit of, I said, just different kinds of problems. But if you start with a percent, it's easy to change to decimal, and it's easy to change to fraction if you're on the tune to reducing and being able to divide by 2. In that case, you could have divided by 4. Yeah, you could have divided by 4, the very first thing, and you would have had 17 over 25, 17 divided by 25, 17/25. All those ways that we use that expression for fractions. So let's see the other way around. Let's take it with our next problem here. How about it? I've got 7/8, and we're going to write that as a decimal and as a percent. Let's do it as a decimal first. Let's do it as a decimal first. Now, remember, and that's why I mentioned this a little bit earlier, that expression, this fraction means the numerator divided by the denominator. So when I said a minute ago, 17 divided by 25, when we reduce that fraction down, it's a division problem. It's just a little division problem, which we're not going to take any further than what we did, 17 divided by 25. This one we want to make into a decimal, and then we want to find a percent. So here's the simple strategy, very simple strategy. We're going to divide the 8, and we're going to divide that right into our 7 there, right into the 7. Now, notice I put a decimal point there because that's where it goes. It comes after the 7 in this problem, all right? And you know, I know, we all know, 8 will not divide into 7, right? So what we got to do, folks out there? You know the answer. You know where we're going. We're going to put a 0 in there because that fills a nice void that we need, a number right there. We don't want to put any other number but 0. Now we're going to divide that 8 into 70, and I'm going to think a little bit. It doesn't go quite 9 times because 9 times 8 is 72. So I'm going to be peeking at, look at what happens with 8. Take a peek at that. Let's see. 8 times 8, you're going like, well, Ernie, I bet since you've written it up there and you can't erase, you're going to keep it, right? It's right, but let's see what happens. 8 times 8 is going to give us 64. And you know what? We're going to subtract from there. Brings us 6. Does that help me? Well, it's a different number, so that means I need to keep working with the problem, all right? If I started getting the same number, I would have a repeating decimal, be all over. We'd be all over, okay? But we aren't repeating yet. We may do that in a minute, yet we may not. Let's find out. The secret is out. We're going to see what's going to happen. Guess what? Fill another void right there. Put in that 0 and bring it straight down. Join the 60. We can take 8 into 60. Now, it won't go even. It won't go evenly. Because remember, we said 8 times 8 is 64. That's too high. So let's bring it down a number. Let's try the 7. Let's try 7 right in there. And hopefully out there, folks, I say it a lot of times, but I'm going to say it again today. Know your times tables. It makes it so much easier to do this thing. 7 times 8 is 56. Now some of you are going like, I thought it was 54. No, it's 56. There's a 6 in that problem, all right? So be sure, 56 is where we're looking, all right? Drag it on down. And again, we're subtracting now. So I can subtract 60 minus 56. I get a 4. Again, it's a different number, so we're going to keep playing the game. Bring another 0 down, all the way down, and we got a 40. Now, I see something that's nice now, all right? Do y'all see something that's nice out there? I see 8 going into 40 5 times, even. It goes in there even. How do I know that? Times tables. 5 times 8 is 40. So let's pop a 5 right in there, and we go 5 times 8, crank out a 40, and hallelujah, we're done, all right? There's a 0 on the end down there, all right? Nothing left over. Now, the question is, where's the decimal? Because that is, folks, what we're looking for. Where are we going to put the decimal? We are going to rise it straight up, right up there in front of that 8. And we have 875 thousandths with a th on the end of it, all right, with a th. That would have reduced back down to 7/8 if we wanted to do that. We're going to look for a decimal. There it is. Now, the magic is once you get the decimal, oh, percents are easy. Percents are easy. Remember what we did a minute ago? We moved the decimal 2 places to the right when we went from percent to decimal. This time we're going backwards. So, so where did we move it to the left? Actually, we moved that decimal 2 places to the left a minute ago. We're going to go backwards. We're going to move it to the right this time to crank out a percent. And that's going to be 87 5/10, or you might want to call it 87.5. Some of you like to say, that's 87.5%. And that's the way we hear it so much in our culture and all of the TV and stuff, so I will go ahead and concede that. But that's what it means, 87.5%. Notice once again, we go from that decimal backwards to the percent, shifting 2 places. Always going to shift 2 places. And this time it's shifted to the right. It was in front of the 8, now it is behind the 7. So there's your story, fraction, decimal, which is also a fraction, by the way. It's a decimal fraction if you read it as thousandths. And then, finally, our percent. They're all connected. Folks, they all represent the same value, Just look different. They look different, but they are the same value, same situation. So, let's see what we've got going here. Let's look at a few just special problems here. We have Thurlow and Erlene coming together here. They've had some testing going on. Thurlow has gotten a result back on a test that he made 75.6%. I believe he probably would have gotten rounded up to a 76, but we'll go with what they gave us, all right? And it says Erlene got 35 out of 45 correct answers on her test. Who scored higher? Well, I guess we need to translate Erlene to a percent. Need to change her to a percent. And we're going to use a calculator on this because these numbers aren't quite so sweet, all right? But let's see what's going to happen. First of all, we know this is established. That's Thurlow, all right? He's got proud bragging rights. He made about 76% on that. That's 3/4, a little over 3/4 there. We're actually right on 3/4 with a nudge, a little 6/10 of a point. Let's see what 35 out of 45 is going to translate to. And I'm going to go back to our percent over 100 formula. We're going to use a proportion on this, all right? So we're going to take that, we don't know what that percent is, right? So, but we do know we started out with a 45 problem test. Erlene got 35. Way to go, Erlene. I have no idea what that's going to give us. And you know what? We don't know either. So we're going to have to figure it out. We're going to call it N. What's the percent? We always put that percent over 100. Let's play the cross multiply game. All right, folks, y'all are out there ready to cross multiply? Yes, raise your hand. Oh, yeah, I can't see if you're raising your hands or not, do I? Let's go ahead and do this thing, all right? We're going to take 45 times N, and we're going to write 45N right below here, okay? And we're going to easily come along here, and we're going to take 35 times 100, which is not hard to do either. Simply throw in 2 zeros, and we've got 3,500. Now, the reason I like using these proportions, some people ask me, Ernie, why do you do that? Well, it tells me when I need to multiply. It tells me when I need to divide, all right? At this point, it's all about division. It's all about division. I don't like the look of it, but you know what? When I don't like the look of a division, and that one looks a little complex, you know, we got the calculator. That's why they were invented, okay? So they could help us with percent problems that aren't pretty. Sometimes you get a problem that will work very nicely. You divide by 100, you move the decimal 2 places. That's easy. But this one, I don't think it's so pretty. So let's go to the calculator, guys. Take me over there, if you will. And let's do the division. Simply 4,500. And we're going to divide that by 35. Is that right? No, that's not what we want to do. Y'all get me straight on this. 3,500. That's the ones the zeros are on. And we're going to divide by 45. Wow, get carried away on these numbers a lot of times. All right, ladies and gentlemen, let's get that drum roll going. Let's see where we're going. That was a short drum roll, wasn't it? 77 and a little bit over. All right, 77. Looks like a repeating decimal there. You say, well, Ernie, it didn't repeat with the last number. They rounded up for you. Calculator eventually says, tired of putting 7s down there. So it rounds it up. So it looks like we actually have about, and it didn't really say how we're going to round it, but I'm going to, since we went to the nearest tenth here, I'm going to bump it up to the nearest tenth also. So we're going to say 77 and about 0.8%. All right. Wow. Who's did better? Looks like Erlene has won by about 2 points, a little over 2 points there, all right? So Erlene, you get bragging rights on this one, all right? Because as we said, and there we go, all right? Now, in this case, there's our final situation there. You can compare them very easily, and you see that, yep, Thurlow is the winner. Thurlow is the winner, all right? Now, that's what a lot of times we really worry most about percents is how well did we do? Or what was our number out of a certain number that we did right or wrong, okay, kind of thing. So let's take another look here. Lawrence is taking a test. Let's see what he's got going here. Said he scored 75% correct. That's 3/4 on a test while getting 36 answers correct. We want to know how many questions were on that test. Because a lot of times we hear the answers, how many you got correct, what your percent was, but sometimes people never tell you how many there were. Well, you know, you can find that out. You can find that out. And we're going to go back. We're going to go back to this little formula I just put up there. This base underneath, part over base, all right, equaling percent over 100. Now, we got the percent. We've got the percent. We know how many he got right. What we want to know is where did we start from? What was our base? There's going to be, right there's your question mark. There's our n, x, whatever variable you want to put in there, my friends. I like n for number. And let's see, 36 has got to go somewhere. Put it right there on the top. That's how many he got right, okay? Everybody with me so far? Again, the part, how many he got correct, was 36. The base, how many questions did he have on the test? We don't know. 75, we already know the percent he got right was 75 out of 100. So we're going to find the big answer n, all right? It's time to cross multiply again. Let's cross multiply. We got 75n going in one direction. There it is. And by the way, some of you are getting new to this that have not done much multiplication or cross multiplying. We know we have younger viewers out there, and some of you are not used to. You may wonder, why do you always put 75 in front of the n? It's just easier to tell if that number is what we're going to need to remove. If I put in 75, I might think that's an exponent if I don't make it big enough. And even then, I mean, it still is multiplication, but it's so much more conducive. We have call this thing a coefficient when the 75 drops in front of the variable, all right? So we're going to use that coefficient in the front instead of in the back, okay? It's just saying 75 times n, and there we are. Now let's go the other side. Let's do 36 times 100. Again, we can do that one in our head. Why? Because I've got two zeros hanging on. So it's going to be 3,600 and working us here, all right? And you know what? Again, I look at those numbers and I'm going like, ugh, I do not really want to have to do a lot of division by hand on this. All right, so let's go. Let me cover up the calculator just a second. Clear it out. We're good. Let's go and check out, see what we're going to get. This time I'll try to make sure the numbers go in the right order first thing. We're going to put in 3,600. And dear friends, we're going to take and divide that by 75. Let's see what we get. I get 48. That sounds good to me. You're going like, why does that sound good to you? I'm going to show you here in just a minute. By the way, that would be 48 questions. We always like to know, what are we talking about? Sometimes we're talking about a percent. This time we're actually talking about an actual number, all right? How many questions were there? Not 48%, but 48. Now, the question I was going to ask you all is, if we take 36 and we divide it by 48, the question is, will we get 75%? That's how we would check. Now, I'm going to do a little fun thing here. I notice that both of these can divide by 12. And that gives me 3/4. And you know what I know about 3/4? I know that it is 75% or 75 cents if we think about money. So I know this is going to come back to our 75%. They are the same. They are the same. They will attach to each other very well. So there's an easy way to check. Easy way to check. He got 3/4 correct. That's 36 out of 48. All right. So that's another reason why it's nice to know those equivalencies, we call them, from fractions to decimals to percents. These little benchmarks, we call them, that make things easy for us. Make things easiest for us to recognize. All right. So a potpourri of percents. We've seen all sorts of type problems coming our way so far. Let's see what our next one has to do. All right. We have a monitor that costs $80. Ooh, this one's a little more complicated, friends. Hang with me on this. Let's read carefully. After a 40% discount is subtracted. So when we have a discount, that means we saved. Now, how much did it originally cost? That's where we're going. So first of all, we're going to talk about the 80. What does the 80 stand for? It's cost. It's what you paid after. It's not the base. It's not where we started. It's where we finished. So it's going to be our part up here, if you will. We're trying to figure out, where did we start? We will call that lovely thing n, all right? We'll make that n look a little better. There we go. Now, percent. A lot of you are going on here and say, oh, put a 40 in there. Now, if I put a 40 in there, let me caution you here. That's not going to get us where we want to go. That's not what we have. The discount was not 40%. The discount's 40%, but it was not $80. All right? That's what we're paying after the discount. So you say, oh, Ernie, that makes us think? It does make us think. That means we kept 60% of the original cost. All right? So we're going to put 60 over 100. Again, where did that come from? We subtract 40% from 100%. All right? That's where we get the 60. That's where we get the 60. Now, let's do our cross multiplication, and we're going to see how much this crazy thing cost. All right? So it looks like we are going to keep 60% of the price. We'll find out where this thing came from. Cross multiply again. We bring that 60 times the n. There we go, 60n. We play the other side, and dear friends, we got 3 zeros. Means 8,000. 8,000. All right. So far, everything is good. This was our cost. This is where we're going to start. Here we go. We had 40% originally. We're discounting, but we are going to keep 60%. Is everybody good on that? And of course 60 goes over 100. Now again, I'm going to say let's go play the calculator game here. Let's do 8,000 and we'll divide it by 60. See what we get. Ooh, a repeating decimal. What are we going to do with that? Well, we're going to basically say that cost was about, since it's dollars and cents, we're going to give it $133.33. That was not so easy to check, is it? But you know, you could come back and you could divide 80 divided by 133 and put your decimal, repeat as far as you could. You should come very close to 60%. That'd be back to 60%. So again, there you go. There you go. And that's what we have, all right? Sometimes the problems aren't always pretty, but you know, it's money. You guys know how to do money. Dollars and cents, et cetera, okay? Now, got one more coming up here. Let's see what's happening on this one here. A $75 dress is marked with a 40% discount. And then it was on sale beyond that. They gave it another 30% discount at the register. What's the final price before tax? Now, first of all, let me dispel a myth here. That does not mean we're subtracting $40, folks. That does not mean we're subtracting $40, all right? We're going to take 40% of that dress and subtract it, all right? And I wish it were $40 for those you would like to get a dress like that. And then when you did $30 more, you'd be down to $5 and you'd be making out like a bandit, all right? But no, it's not going to work that way. So let's check and see what's supposed to happen. First of all, this is our starting point. This is our starting point. So it's going to be our base. It's going to be our base. We are going to figure out how much are we going to save. What's the actual money? Again, it says not $40. Don't do that. Don't do that. That's 40%, not $40. So here we go. We're looking for it. We don't know what it is. We'll call it in. We'll call it in. On the other side of the picture, we are going to have 40, and we'll divide that by 100 because that's the way it works, percent. 40 over 100. We're going to do a nice little cross multiplication here, and we're going to see just where does this craziness take us, all right? So as we look here, let's go ahead and cross multiply, and we'll take 100. Oh, 100 times in this time. Some of you are going like, ooh, that's different. It is, because we get 100 times in. Now, this time I think we could do this some in our head, but you know, I'm going to go ahead and put it on the calculator so some of you go like, where'd that come from? I'll show you. We're going to say 75 times 40, or 75 times 40. And let's see what we get. Times 40. Have y'all ever noticed that on the calculators, a lot of the times comes out, it looks like an asterisk? That's just the way it is. Don't get nervous about that. It's just easy to indicate because X's and times can look the same. And here we go. We get 3,000. And now we're going to divide by 100. And this part's easy, my friends, because see what happens when we divide by 100? 2 zeros will cancel out. That's what happens, those 2 zeros. You're left with, and by the way, these two completely cancel out, don't they? And it leaves us with n equaling 30. Now that's dollars. That's dollars. That's how much you save from 40%. Notice I didn't say $30 from the 30%. No. It's $30 based on that's 40%, all right? So let's take the second half of this baby, all right? New price, y'all tell me. We got to subtract that 30 from 75. And that's going to give us 45. 45, let's go ahead, take another n. And this time we're going to be taking 30 over 100. Cross multiply. We've got 100n going here. And let's take real quickly on the calculator just to make sure we don't mess up here. We're going to do 45 times that 30. That's cross multiply, my friends. There we go. And that gives me 1,350. Divide by 100. And that's going to leave us with, remember we move those decimals in 2 places when we divide by 100, $13.50. Now, remember we had 45. we're going to subtract $13.50. All right, so let's see, $13.50 from 45. Let's clear this out and see what we get real quick. 45 minus $13.50. Here we go. And we get $31.50. That, dear friends, that's what we ended up with. Okay, so remember, that was here. That was $31.50. And hey, there's your final cost. Good savings, but you got to be careful. Hey, thanks for tuning in this afternoon. A little potpourri of percents. Hope you got a good angle on them. And we'll be back again tomorrow with another great topic of some sort. Hope to see you then.